I'm generating a very nice sine wave out of this BK Precision function generator. And I've got my frequency counter hooked up to the, I was just taking a measurement off the sine wave, and I've got it feeding into a channel here. What I want to demonstrate right now is the Fletcher Munson effect. So the first thing we're going to do is we're going to watch the power meter on our VU meters here as I bring the frequency up. And what you're going to look for and notice is that the actual power output is virtually the same for this frequency band. I'm going to sweep. I'm going to start at, unmute this. Okay, and see where we are on our VU meters. Now this is going to move a little bit, but the point I'm trying to make is that it doesn't move very much. Okay, so I'm going to sweep upwards. Actually, okay, so there you can see I think I went all the way from 85 hertz all the way up to 11K. Which is, human hearing is generally between 20 hertz and, I guess like around 20K, I guess. That's pushing the limits pretty much. Anyways, what you notice is that the power stayed pretty much the same for the most part. Now we're going to do that again, but we're going to instead this time, realizing that the power output is the same, we're going to keep our eye on the frequency counter. We're going to try and note where the sound is perceived by us to be louder or quieter. So let's try this again. So if I muted that channel, I'm going to bring the frequency up. Oh, it's pretty sensitive. Hear that pretty well. Okay, now it's starting to really sound loud. Really loud. Right just before 1 kilohertz. It still sounds pretty loud. Especially right around here. Especially right around there. Still sounds pretty loud. As we get to 5K, it starts to taper off. And everything above here you can still hear, but it doesn't somehow it just doesn't seem as loud. There's a little over 11K. And that does not seem as loud as, say, 2.3K or 2.6. I mean, that's fairly loud, and certainly is louder than that. Big time. I don't think you can dispute that. But the interesting thing, of course, is that all of those frequencies were being output at the exact same power level, but our perception is that little under, I would say a little under 1K to about 5K sounds the loudest. That's where the human hearing is the most sensitive. That is a very helpful thing to understand when you're in audio engineering or mixing music or just doing music in general. What I've been finding, just as I've been working, for whatever reason, I don't know why, but today's world, people like to do this. This is like people's favorite thing to do, right? This is like you go to any EQ and look at it. Your chances are you're gonna see that. What you're doing there is you're taking out all of the frequencies that people can actually hear. I'm not sure why, or why people. I think it's because it's a smoother listening. I'm not sure really. It's all personal preference. But me personally, when I'm performing live, I actually boost this a little bit around the 2K. I find it makes my vocals a lot clearer, easier to hear. They just sound more powerful. So I tend to do that now. It's all personal preference, but just be aware that from here to here, these three bands here, these are your important bands. That's where the human ear is the most sensitive. So just be aware of that. Nobody likes mids these days. Everybody likes to jack the bass and the treble and just kill the mids. But I would say maybe you should take I'm just saying that all I'm saying is the human hearing is the most sensitive there, and that is a good demonstration of the Fletcher Munson curve. So I hope you learned something from that, and I hope that helps with mixing and just music in general. And thanks for watching.